Now let's take a look at what kind of scenarios we will face when we choose the better alternative. So when we make investment decisions, there are two types of decisions we will face. The first one is called investment alternatives. Investment alternatives means each alternative has an initial investment, right? You need to spend some money at the beginning. For example, you want to buy equipment, so that equipment can produce something, then you can sell, and then you can get revenue and a profit. So you need to spend some money at the beginning. And those investments can produce positive cash flows resulting from increased revenues, right? You sell the product, or come from the reduced costs, right? Like the energy saving equipment that will cost less energy, so you can save some energy cost. That's also kind of positive cash flows, or both. So either it can make money or it can save money, but all of them, it will give you net positive cash flows on the diagram. And do nothing is usually an implicit investment alternative. So if you have two options, you need to spend different level of capital investment at the beginning, and then they both will give you some positive cash flows in the future timeline. Just keep in mind that do nothing is always one option out of that two. So if you convert all the cash flows to the present time, for example, and then the present worths are all negative, which means you're losing money, then you will consider do nothing, because if you do nothing, you don't lose any money. Although you don't gain anything at all, but you don't lose, right? So losing some money is not always worse than doing nothing. So do nothing is always an option for the investment alternatives. Now let's take a look at a very simple example. This is what we call investment alternatives. So we have alternative A and B. You can imagine that they are just to buy some equipment, and then the equipment will produce some product, and by selling the product, you can earn some annual profit, right? So alternative A, the capital investment is 60,000. So you need to spend 60,000 to buy equipment, and then the equipment have a capacity to produce the product, and so your annual revenues less expenses. So revenue minus expenses, that will be your profit. So your annual profit will be 22,000. And you see the negative sign, which means it's an expense, okay? And the positive sign, which means it's a saving, okay? So this is what we call the investment alternative, because it requires some initial investment, and it gives you positive cash flows. And alternative B is similar, but the initial capital investment is different. It's 73,000. So the equipment is more expensive, but you can see that the profit is bigger, and every year maybe the more expensive equipment can produce more products every year, so that you can get more profit. So we want to compare which one is a better choice. Okay, you cannot compare like these two and these two directly, because they are MARR related. You need to consider the interest rate. Okay, so how do we do that? So first, we need to draw the cash flow diagrams for these two scenarios. So let's see, we divide this screen to two parts. And so for the A option, the cash flow diagram will be having 4 years, 1, 2, 3, 4, right? And then at the beginning, you have a capital investment, which is 60,000. So it's going downward, 60,000. And every year you have positive 22,000. So that's arrows going upward. And it's annuities because they're all the same, right? And it's annuities 22,000. Okay, so wow, this is very easy. So we need to convert. So the method we use is we either convert everything to the present worth or to the future worth or to the annuities annual worth. Okay, those are the methods we have learned in chapter 5. Any method is working, but I prefer to convert everything to the present worth because that will give me an idea of how much it is right now. Okay, so we need to calculate the PW for option A. Okay, so we say PWA, and the PWA is made of two parts. So part 1 is from the initial investment 60,000 and it's negative, right? And so you want to convert this present worth to present worth. And then PW2, that's the second part, is from the positive annuities, which is 22,000, right? So basically you want to convert annuities to present worth. So PW1, it is already present value, so you don't have to convert, you don't have to check the factor. So it's 60,000. PW2, which is positive, right? And you want to convert annuity to present worth. So it's the formula is A times P/A MARRN. So A is 22,000. The factor is P/A. MARR is 10% here. And then N is number of periods, which is 4. So it's 22,000 times, let's check this. This is table for I equals to 10%. So find P given A, right? So that's the column. No. This is the column. P/A and 4. So this is the factor. So it's 3.1699. So it is positive 9,737.8. Oh wait, not this. Let me see, what's the value of that? So it's 22,000 times 3.1699. So that is positive 69,737.8. Okay, so the PW A is the sum of these two, PW1 plus PW2. PW1 is negative 60,000. PW2 is 69,737.8. So the final result is positive 9,737.8 US dollars. Okay, so which means if you convert all the cash flow back to the present time, your present worth of option A will be positive $9,737.8. Okay, that means you will earn by doing option A, you can earn this much of amount. Now let's consider option B. So the first thing is to draw the cash flow diagram, which has 4 years. At the beginning, you spend more, which is 73,000, and every year you can earn more profit. So you have longer arrows going upward, and A is 26,225. Okay, so that's the cash flow diagram. And then the same thing, we have to convert everything back to the present time for option B. So we say it's the present worth for B. And still we have 2 parts, PW1, PW2. PW1 is from the 73,000 initial investment. So you want to convert P to P. PW2 is from the annuities. They're positive, right? 26,225. So you want to convert annuities to present worth. So your PW1 is already present worth, so don't have to convert anything. Just copy the number. Don't forget about the negative sign. PW2 is positive A times P slash A, M, A, R, R, and N. Now the A is 26,225. The factor is P slash A, 10%, 4. So 26,225 times what? Times the 3.1699. Okay. This is 26,225 times 3.1699, which is positive $83,130.6275. Okay, and then your PW for option B is the sum of PW1 and PW2. Okay, which is negative 73,000 plus positive 83,130.6275, which will give you a positive US dollar 1,030.6, which means if you do option B, you will end up earning $10,130.6. So you want to compare the PWB and PWA, and the comparison will give you PWA smaller than PWB, and they're all positive numbers, right? So you want to have something can help you earn more, right? So PWB will be the one to choose. So you choose B. Okay, so this is how you decide which investment alternative is better.